Welcome to my channel, guys. Make sure you support by liking as well as subscribing to my channel if this is your first time visiting my channel. In today's video, we're going to look at DIC. So DIC is basically disseminated intravascular coagulation. Okay, so DIC is one of the important clinical conditions which we need to understand how it comes about. Okay, so we're going to discuss about DIC, what it is, the causes of DIC, the mechanism of DIC, complication of DIC. Okay, so we're going to stick to this objective. Alright guys, so without wasting much of our time, let's get into it. Alright guys, so when talking about DIC, by definition, this is basically a condition in which there is excessive activation of coagulation and formation of thrombi in microvasculature. Okay, so this is what DIC is. Okay, so it is also known as a consumptive coagulopathy. Okay, this is because in DIC there is consumption of platelet as well as coagulation factor. Right, not only that, there is also activation of fibrinolysis invoking bleeding. Right, so DIC, it is complicated by sepsis. I'll explain what sepsis is. Okay, it is complicated by sepsis. Okay, and you find that a patient presenting with DIC, they have excessive clotting as well as excessive bleeding. So this is the net result of DIC, right? So the net result of DIC is basically excessive clotting and bleeding. Alright guys, enough of definition of DIC. Now let's get to the causes of DIC as well as the mechanism itself and complication of DIC. Alright guys, so okay, so when talking about DIC, causes of DIC, basically, at least even when you have forgotten, at least remember this one which I have highlighted in red. Okay, so there is endothelial injury, sepsis, and massive tissue destruction. Right, at least remember this. Even when you have forgotten everything, at least you remember this. What happens, I'll explain and you're going to understand. Okay, so let's start with endothelial injury. Right, so what is happening is that in endothelial injury there is exposure of tissue factor. Also there is also exposure of Van Willebrand factor, okay, in endothelial injury. Right, so endothelial injury can be due to temperature, which can be extreme temperature. Okay, in this case we are talking about burn. Okay, so in burn you can lead to burn, can basically lead to endothelial injury. Right, also infection, so infection such as rickettsia, also meningococcal, all these infections, they can lead to endothelial injury. Right, apart from that, antibody antigen complex. Okay, so this is seen in type 3 hypersensitivity. Right, so in conditions such as systemic lupus erythematosus, so such condition you find that there is deposition of antibody antigen complex in blood vessels or rather in tissue. So this will trigger endothelial injury. Right, and now once endothelial has been injured, because in the process of injuring endothelium, there is also exposure of tissue factor, also collagen and Van Willebrand factor, as I said. So now this will just lead to exposure of, or rather they will just lead to release of tissue factor because of these factors which we have just mentioned there, like burn, infection, antibody antigen complex. These they will lead to release of tissue factor. Okay, let's go to the next one, sepsis. So when talking about sepsis, sepsis is basically whereby the bacteria enters into the secretion, right? So the microorganism here, they are entering into the secretion. So you know that when talking about gram-positive, gram-negative bacteria, they have what we call endotoxin as well as exotoxin. So those products of the bacteria, they will stimulate the macrophage. Okay, they stimulate monocytes. We know that monocytes, it's differentiated into macrophage, right? So they will stimulate monocytes, and these monocytes, once stimulated, they will start producing cytokines such as interleukin-1, interleukin, as well as tumor necrosis factor, right? These are noticeable cytokines which are produced by monocytes, which has been activated due to endotoxin as well as exotoxin of the bacteria, gram-negative and gram-positive, right? So these cytokines excuse these cytokines, they will lead to activation of protein C, right? So protein C will be activated. Now protein C is very important because once protein C has been activated, it is capable of innervating factor 5 as well as factor 8, which is those are two important cofactors which are needed for the formation of clots, right? So this protein C is capable of innervating those factors once it is activated, right? Then not only that, interleukin-1 as well as tumor necrotic factor, they also lead to downregulation of thrombomodulin. Okay, so this basically leads to also inhibition of clotting cascade. Okay, so thrombomodulin can block the cascade of clotting. Not only that, interleukin-1 as well as tumor necrotic factor will lead to expression of tissue factor, as you can see here. So you see there is release of tissue factor here. Now tissue factor is very important. Once it is released, tissue factor in extrinsic pathway, it can combine with factor 7, and once it combines with factor 7, this we can activate factor 10, and factor 10 can combine with factor 5, which is important cofactor. Factor 5, remember we said protein C innervate factor 5. So factor 5 and factor 8, these are two important cofactors. So once tissue factor together with factor 7 activates factor 10, factor 10 will combine with factor 5, and these two complex, they are going to activate or rather convert factor 2, which is basically prothrombin, into thrombin. And then thrombin, we know that it's able to convert fibrinogen into fibrin, right? And fibrin is what we want. Fibrin is basically a clot which is insoluble form of fibrinogen, which is soluble, right? So this is what will be happening in sepsis. So there will be activation of protein C there will be also down regulation of thrombomodulin, and there is also exposure of tissue factor. Alright guys, so enough of sepsis. Let's go to massive tissue destruction. So massive tissue destruction, basically it can come about due to surgery, right? Also due to trauma, like a physical trauma, and extensive burn. Okay, so in case of extensive burn, you can have also massive tissue destruction. Here, remember we said extreme temperature, but here we have added extensive burn. These extreme temperature, they can also be burn, right? It can also injure the endothelial lining. But what is the whole response of these? The whole response is that they are going to be resulting into the release of tissue factor. Now, I have already explained how tissue factor leads to clot formation. It combined with factor 7, and then those two, they form a complex. A complex goes and activate factor 10. Factor 10 form a complex with factor 5. Factor 5 and factor 10, they convert prothrombin into thrombin, and then the thrombin is able to convert fibrinogen into fibrin, right? So we have our clot, right? So that's what is happening here. So from there, what you see that we have thrombosis. Now this is widespread, right? This is widespread thrombosis, which is in microvasculature, right? So this is what is happening. Okay, so apart from that, we know that if we have widespread microvasculature thrombosis, this will basically lead to vascular occlusion, right? So we have vascular occlusion here due to this thrombosis. If we have occlusion, basically we have ischemia, right? So we have low blood supply to that tissue, right? So we have ischemia here. Alright guys, so this is how DIC leads to clotting. Remember, from our definition we said the net result of DIC is excessive clotting. So this is what is happening. So we have widespread microvasculature thrombosis, which is basically leading to occlusion of vessels, and this leads to ischemia. Alright guys, so now you see that this is basically the mechanism of DIC. Now let's look at the complication of DIC. So some of the complication, remember we said DIC is basically complicated with sepsis, which we have just explained, and sepsis. Take note, sepsis is very important because if a condition is complicated with sepsis, that means that condition is very dangerous, right? Because here we have bacteria which are in the circulation, right? And they can go to any organ. They can easily go to the brain, they can easily go to the heart because they are in the circulation. So sepsis is very important. Okay, so some of the complication is that if we have widespread of microvasculature thrombosis, this will basically lead to activation of plasmin. Now plasmin, once activated, it is capable of breaking down fibrin. It can break down fibrin in the process called fibrinolysis, right? So basically fibrinolytic pathway is whereby we have initially we have tissue, we have plasminogen. Okay, so plasminogen is going to be converted into plasmin by tissue plasminogen activator, and then the plasmin is able to convert or to split fibrin into is able to break down fibrin, right? And then all what we have from there, what we are going to have with that, we are going to have bleeding, right? Because here now we are splitting the clot which has already been formed because of plasmin, which is capable of splitting the clot. So we have bleeding. Okay, so this is how bleeding comes about. Not only that, we also said in DIC there is consumption of platelets, right? So if we have consumption of platelets as well as coagulation factors, so if we consume those factors, what we are going to have, our overall result is going to be DIC, is going to be bleeding as well, right? Because we don't have factors which are capable of causing a clot formation. Now, if you can't form a clot, then it means we are promoting bleeding. So we have bleeding here. All right. So that's basically how DIC can lead to bleeding in patients. Okay. Also, excessive clotting at the same time, which means DIC can be complicated and is very dangerous in clinical setting, and the understanding of how it comes about becomes very important. Alright guys, so this is how we summarize DIC, and this is all what we need to know about DIC. Alright guys, until next time.